So this video is going to review the process for finding greatest common factors and least common multiples, primarily using the Venn diagram, and then give you a few practice problems there at the end. So first we need to go through and remember what it is that we're finding. And so for both GCFs and LCMs, we need to have at least a pair of numbers. Now we can have 3, we can have 4, we can have as many as we want, but we need at least 2 because the C in both GCF and LCM stands for common, so we need things to find in common. When it comes to the GCF, we're looking for the greatest common factor. The key point here being factor, and as a vocabulary term, that means a number that divides into our numbers. So the factors of 20 are things like 1, 2, 4, 5, 10, and 20. Factors of 24 are things like 1, 2, 3, 4, 6, 8, 12, and 24. So when it comes to finding common factors, we're just sort of finding the ones that they have in common. The 1 they have in common, the 2 they have in common, the 4 they have in common, and that's about it. So if these are the factors that they have in common, then the greatest common factor is just the greatest of the common factors, which in this case is 4. Now this works, this strategy of just writing out the factors only works if the numbers are small enough that we can be guaranteed not to miss any factors. In a lot of cases, though, that's not going to be quite as easy as it sounds, so we need to find a better way of doing it, and so we use prime factorizations and Venn diagrams. The least common multiple, on the other hand, the key word here is multiple, meaning the list of numbers that you can generate from either 20 or 24 just by multiplying it by whole numbers. So you can generate 20, 40, 60, 80, 100, 120, etc. From 24, you can multiply by 2 to get 48, by 3 to get 72, by 4 to get 96, by 5 to get 120, etc. And so we're still looking for multiples that they have in common, but because they're multiples, we're going to look for the smallest multiple they have in common. We can always just multiply 20 and 24 and get 480, but we can see that 120 is smaller than 480, but it's actually a number that they have in common. So 120 is, in this case, the least common multiple. And so when we're trying to find the greatest common factor and the least common multiple, we need to find a way of breaking down numbers into easy-to-use smaller parts of themselves, and that's where we get into the prime factorizations. So we can use the prime factorizations, and with the prime factorizations, the help of a Venn diagram, to break down 20 and 24 into their number DNA, which is what we call the prime factorization, and then compare the primes that make up 20 and the primes that make up 24 to determine what they have in common and what we would need to create either of them. So let's take a look at that here. Now 20 in a Venn diagram can break it down. The factor tree is 2 times 10, and 10 is 2 times 5. So 2, 2, and 5 are the primes that make up 20. Now 24 is 2 times 12, 12 is 2 times 6, and 6 is 2 times 3. So 24 is 2 times 2 times 2 times 3. And so we can see that there are some numbers that they have in common, some primes. They share a 2, which in a Venn diagram goes into the center, and they share another 2, which again in the Venn diagram goes into the center. So they share 2 copies of the prime 2, so in the center we only put 2 copies of the prime 2 because otherwise we would have more than that. So now we still have, if we covered up the right circle, we'd have the primes that make up 20. If we covered up the left-hand part, but not the common part, we'd have all the primes that make 24. And so now for the greatest common factor, for this greatest number that can go into both 20 and 24, we just look at the common primes, and that's 4. To find out what we need to create, or it's 4 because we multiplied 2 times 2. To find out what we would need to create either 20 or 24, but not both, we just need to find out, well, how many 2's do we need, how many 3's do we need, etc. And it turns out that this entire Venn diagram, everything that's left after we've taken out the extra copies and put things in the center, that is our least common multiple, because we can take the 5, the 2, and the 2 to create 20. We can take the 2, 2, 2, and 3 to create 24, but we don't have any extra primes. We don't have extra copies of 2 or 3 or 5. We have exactly what we need to create either 20 or 24. So again, the GCF is everything that's in the center of the Venn diagram. The LCM is everything that's in the entire Venn diagram once you've looked at the primes that they have in common and everything like that. So let's go ahead and look at 3 practice problems here. Go ahead, pause the video, work out the GCF and LCM of 15 and 40, and come back when you are ready to go through the answer. So 15 is 3 and 5. 40 is 5, 2, 2, and 2. They share a 5. So we take it out of each side of the Venn diagram, and we put it in the center. That means our GCF, which is in the center, is 5. And our LCM, which is everything that we have left, is 120. 2 times 2 times 2 times 5 is 40, and 40 times 3 is 120. Now let's take a look at 35 and 32. Go ahead, pause the video, find the GCF and LCM of 35 and 32, and come back when you are ready to go through the answer. So 35 is 5 and 7. 32 is just 2's. It's 8 times 8, or 8 times 4 rather. So there are 5 2's that make up 32. And as we can see, they don't actually share any prime factors. However, there is always one factor that numbers have in common, and that is 1. So the GCF of these two numbers is actually 1, even though that doesn't look like GCF, but just look at the blue lines there, that's GCF. Then, in order to find the least common multiple, we multiply everything that we see in the Venn diagram. So in this case, it is just 32 times 35. And 32 times 35 is 1,120, which is the LCM. So in this case, if they don't share any prime factors, they have a GCF of 1. Remember, we call those relatively prime. And then their LCM is just the numbers multiplied by itself in this case. And then final practice problem, let's look at 10 and 70 and see what you can do for coming up with a GCF and the LCM of these two numbers. So 10 is 2 and 5. 70 is 2, 5, and 7. They share a 2 and a 5, which means that the 10 circle on the far left side is going to be left entirely blank while we do this. And then we have the 2 and the 5 that they share that are going to go into the center. And so the GCF is 10. And the LCM is everything that's left, but there's nothing left in the far left-hand part of the circle, so it's just 70. 70 is our LCM. In this case, 10 is actually a factor of 70. So it is, and it is a factor of itself. Every number is a factor of itself. And so we have 10 is the GCF and 70 is the LCM. So remember that when it comes to the GCF and the LCM, what we're looking for are the ways that their prime factors interact, and we can use their number DNA, their prime factorizations, to determine the greatest number that is a factor of both and the least number that is a multiple of both.